and FG are parallel. Segment EG is 12 units long. Segment EB is 2.5 units long. BD is parallel to FG. Okay, so first thing is we can mark these segments here as being parallel. Since these are parallel, we can mark our congruent angles. And that means we have similar triangles. So now we can write a similarity statement. So let's go top to bottom, left to right. Let's go with triangle FGE, similar to triangle BDE. So, and now we can write our proportions. So we're going to use first two letters, FG over first two letters, BD. It's going to be equal to, we can do our first and last letter, FE over first and last letter, BE. And then we can do our last two letters, GE, over last two letters, DE. So that's our formula. And now we can plug in pieces of information that we know. We already know the length of FG. So FG is 15. We know the length of EG. EG is 12. We know the length of EB. EB is 2.5. And now we can start to also label this on the graph. So here on the diagram, diagram. So here's 12, and then EB is this one down here. So that's 2.5. Okay. So let's start plugging in some information and see what we've got. FG, so we can replace that with 15. BD, we don't know what BD is yet. FE, we don't know that one yet. But BE, we know BE is 2.5. And then GE, we know that one's 12. And then DE, we don't know that one yet. DE. Oh, and we actually do have some more pieces of information here. BD, actually we do know what BD is. BD is right there, BD is 5. So we can replace that one with 5. And we can mark that BD equals 5. All right, so now, yes, we have 4 pieces of known information. 1, 2, 3, 4. All right, so now we should have enough information for us to solve this. So we can use our first proportion right here. 15 over, I'll do it over here on the left side. 15 over 5 equals FE over 2.5. So there's lots of strategies for solving proportions. The strategy that I'm going to use for this one is I'm looking at the numbers 15 and 5, and I notice that this is basically 3. So I'm just going to simplify that to 3. And then this is going to be FE divided by 2.5. So I just need to multiply. Multiply there, and we'll multiply over here. These will cancel, and we'll get the length of FE as 2.5 times 3. So 2.5 times 3, we get 7.5. There's one length. And now we can do a proportion. Let's do this one in green. We can do a proportion on the other side to get the length of DE. Now that we know that the length of FE is 7.5, we can either use this proportion, or a good strategy for this situation is, because we calculated the length of FE, it's better to avoid using it and instead try to stick to numbers that we've been given, so that in case we made a mistake, we don't make an extra mistake calculating DE. So I'm actually going to use this one and this one. I'm going to use these two to set up my proportion. So I guess I'll do this one down here. So we'll do 15 over 5 equals 12 over DE. And just like last time, I'll simplify this to 3. 3 equals 12 over DE. Now this time, I'm going to need to multiply, but instead of multiplying by the number that's on the bottom, now it's a variable that's on the bottom. It's the length of DE. So I'm just going to multiply both sides by DE, whatever that length is. That's going to make these cancel out. And now I'll do this in a different color so we can see that. Now I've got DE times 3 equals 12. So now we can divide by 3 to make these cancel. And 12 divided by 3 is 4, so the length of DE should be 4. So now I can mark in my added sides. I know the length of DE is 4, and I know the length of FE, this whole length right here, is 7.5. And if this length, the whole length is FE is 7.5, BE is 2.5, that means this one right here has to be 5. So that's FB. And then if the distance from G to E is 12 and from D to E is 4, that means this one right here must be 8. And now we have located all of the missing lengths.